My name is Omar and I represent our DSD project, which is a Launchpad mixer containing 12 buttons. Each button play different beep sounds, and I will show you the design of our Launchpad. Here the Launchpad is consisting of 3 rows. Each row contains 4 buttons. When you press the button, this LED will light, indicating that this button will play the piece of beep or piece of music. And this button is recognized by the FPGA pin assignment, which I will show you. Here we used these pins in the FPGA. Each pin is assigned to each button in the Launchpad, and when you press the button, the FPGA will recognize this by this pin, and the piece of code will be executed, which is related to this specific button press.
My name is Sarah Maxon and I would like to talk about all of the components that we used in our project. First of all, we used the breadboard to integrate the circuits. Also, we used push buttons to trigger the signals. We used LEDs to make visual effects. As for the power source, we used a 9 volts battery to give enough power. Then we used a voltage regulator to avoid high voltage. Last but not least, we used a speaker to produce sounds with different frequencies.
My name is Omar Kamal. I would like to talk about the connection in the circuit. We have a 9 volts battery. We're using it as a power source. Also, we have a voltage regulator to reduce the 9 volts into 5 volts, which is the acceptable voltage for the FPGA. Each push button has a circuit, which is we have an LED that is connected to the 5 volts. In series with it, there is a connection with the push button, and then the push button is connected in series with the ground. Also, we have a pin connected in parallel between the LED and the push button that drives a signal to the FPGA.
And now I would like to talk about sending the input signals to the FPGA. If the push button are released, the active high signal flows from the source to the FPGA. However, when the button is pushed, the signal flows through the LED and then to the ground, which results in an active low signal to the FPGA. And so the code in the FPGA is triggered by the active low signal.
Okay, my name is Ahmed Magdi, and here we will teach our FPGA how to play music. FPGAs can easily implement counters. For example, a 15-bit counter is going to count from 0 to 2 power 15. Assuming we have 25 million hertz clock available in our code, and the counter is free running. In more details, the counter 0 looks like a 12.5 million hertz signal. It's updated to at 25 hertz. Million hertz with alternative values from 0 to 1 and so on, 0 to 1, 0 to 1 and so on. So it looks like at 2.5 million hertz signal.
My name is Laila Magdi. We have 12 buttons as inputs from B1 to B12. We will start with the ONO statement with the first button. We will begin. If the first button equals 0, we will make the enabled equal 1, so that to make sure that only one button has been clicked. And then we will divide the 25 million, which is the frequency of the clock, with 100 to make sure that we generate a number which is smaller than 25 million, so that the sound can be heard. And then we will do this again for the 12 buttons, but with different numbers to generate different sounds. If the button equals 1, this means that the enable equals 0, and that means that no buttons has been completed.
Now we would like to show you a demo of our Launchpad working.